In this video, our focus is to convert a proper algebraic fraction into its partial fraction, but this time the denominator consists of repeated linear factors. Let's look at the first example. The question says, split this fraction into its partial fractions. What is the checklist? The checklist is first check whether it's a proper fraction or not. What is the definition of a proper fraction? Highest power in the numerator should be lesser than highest power in the denominator. There is also a different scenario in which the highest power of the numerator is equal to highest power of the denominator. Now, in this case, the highest power is a 2 in the numerator. The highest power after multiplication is 3 in the denominator, so it fulfills this category. That means we can start right away. The second thing to notice is that we have x plus 1 whole square. We cannot write this thing as x plus 1, x plus 1. We have to simplify and write this thing as x plus 1 whole square. This makes this a linear repeated factor. It's linear on the inside, but because of the square, it's being repeated. One other question that people ask, can't we just expand it and write this thing as x square plus 2x plus 1 and consider it to be a quadratic factor? The answer is no, you cannot do this. What's the logic behind it? The logic is we should always factorize the denominator. In this scenario, we are doing the opposite. So the story is that we consider this to be a linear repeated factor. And how will we write it? We will write this thing as a constant over the first factor, the normal linear factor, another constant over x plus 1 without the square, another constant over x plus 1, the whole thing square. So that is the setup for breaking a denominator with linear factors into its partial fractions. Now, the process is the same as before. You have to take LCM, 2x plus 1, and these two, the LCM is x plus 1, the whole thing square. Now be very careful. A will multiply with x plus 1 whole square. Similarly, C will multiply with 2x plus 1. But what are we left with? We are left with B. It will multiply with two brackets. First of all, it will multiply with 2x plus 1. But at the same time, it will also multiply with x plus 1. The reason being, this is x plus 1 whole square. Over here, it's simply x plus 1. So one factor is missing. That's why it will multiply out this way. So now our objective is to find the unknown constants a, b, and c. We have the expression 11x squared plus 14x plus 5. It's identical to a multiplied by the bracket square. X plus 1 is inside the bracket. B is being multiplied with x plus 1, 2x plus 1. And C is multiplied with 2x plus 1. So now we can get started in any order. For example, if I say, let us assume a value, let x is equals to -1. Why am I choosing -1? Because this bracket will become 0, which in turn will make a 0. This bracket will become 0, which in turn will make b 0. So I'll be comfortably able to find the value of c. So if I take x is equals to -1, 11 into -1 square, 14 into -1 plus 5. Let me simplify it first. This is 11. This is -14. This is 5. 16 minus 14 is 2. I'm left with a 2. Similarly, on the right hand side, c is multiplied with 2 into -1 plus 1. So therefore, 2 is equal to c into -1. Therefore, c comes out to be -2. That is the answer for the very first constant, which in this case is c. So I found the value of c, which is -2. Let's proceed. The expression is still the same. 11x squared plus 14x plus 5 is identical to a multiplied with x plus 1 whole square, b multiplied with x plus 1, 2x plus 1, and c, I can plug in the value -2, 2x plus 1. Now, our objective is to find either a or b. Let's see which one is more appropriate. Now, I can see the bracket 2x plus 1. In other words, if I say 2x plus 1 equals to 0, in other words, x is equals to -half. That means the brackets with b will make b disappear. C will also disappear. This one was c. And what will I find? I'll find the value of a. So therefore, let x equals to -half. 11 into -half whole square. 14 into -half plus 5. That's 11 multiplied with 1 over 4. That is 14 into -half is -7 plus 5. This comes out to be -2. And 11 over 4 is 2, 3 over 4. 4 2s are 8. 8 plus 3 is 11. That's all perfect. That leaves us with 3/4. So 3/4 equals to a multiplied with -half plus 1 whole square. Therefore, 3/4 equals to half square, which is 1/4. In other words, the value of a comes out to be 3. So that is the second constant that you have found out. So a comes out to be 3. C comes out to be -2. Let's rewrite this expression again. So 11x squared plus 14x plus 5 is identical to a, which is 3 multiplied with x plus 1 whole square. B, which is still unknown, is being multiplied with x plus 1, 2x plus 1. And C, that is being multiplied, and we already know the value of C, which is -2 multiplied with 2x plus 1. Now only one unknown constant is left. You can plug in any value of your choice, provided you have not used it before. So what were the values that you have used? -1 and -half. So let me put in the easiest of all values, that is x is equals to 0. So left hand side is left with a 5. Right hand side 3 into 1 square. B multiplied with 1 into 1 and -2 multiplied with 1. This is 5, this is 3, this is b, this is -2. So 3 minus 2 is 1, 5 minus 1 is 4, therefore b comes out to be 4. So that was the missing constant which we have successfully found. But wait a minute. But actually, what were we looking for? What was the question all about? The question was all about finding partial fractions. So the answer should be in a fraction format. There were 3 denominators. The first one had a denominator of 2x plus 1. The other one had a denominator of x plus 1. The last one was written as x plus 1 whole square. The first one had a value of a. The value of a came out to be 3. The second one, the b, was the numerator. The value came out to be 4. And last but not the least was c. The value of c was -2. So either you can write as it is, or you can write this last fraction as -2 over x plus 1 whole square. We have successfully solved the first worked example. Let's move on to the next one. The second worked example is split into its partial fractions. This time the fraction looks like this: 2x over x plus 2 whole square. First of all, the checklist. The checklist is it a proper fraction? The answer is yes. The numerator is linear. The denominator is after expanding, that's power 2. So therefore, yes, it's a proper fraction. We can get started right away. Second thing, which case is this? This is linear repeated case. So therefore, first of all, you will write this thing as a constant over x plus 2, another constant over x plus 2 whole square. Once you have taken the LCM, it's simply x plus 2 whole square. B remains as it is. It's simply multiplied by 1. Why is this the scenario? Because this denominator of B is the same thing as the LCM. But A is multiplied with x plus 2. The two fractions are identical. Denominator is the same thing as the denominator, but the numerator is also the same. So therefore, 2x equals to A multiplied with x plus 2, B multiplied with 1. Let's start with a simple value. Let x equals to -2. This will make this bracket disappear and hence A will disappear. So therefore, 2 into -2, that is -4. And this A multiplies with 0, B remains as it is. So the value of B comes out to be -4. Similarly, you can first write the identity as it is and then choose any value like the previous example. So if I choose a simple value, the simplest of all, that is x equals to 0. So therefore 0 equals to A multiplied with 0 plus 2. The value of B is known, which is -4. Transfer the 4 on the other side. So 4 is equals to 2A. Therefore A comes out to be 2. We have found A. We have found B. The final answer is to write it as partial fractions. A is the numerator of x plus 2. So that is 2 over x plus 2. And B, which is -4. So I have plugged in the negative in the middle. And this is 4 over x plus 2 whole square. So in this video, we have successfully converted a proper fraction into its partial fraction. And which case was this? This was case number 2, which is denominator with linear repeated factors.